Okay, in this short video, let's do more exercise about this quadratic equations. Remember, the quadratic equations has factorization method. Has a complete, not complete square root method, and has completing square method, and quadratic formula. Okay, so we actually have those four parts. In this factorization method is a tricky one. So, for example, if you have x squared minus 2x, well, let's see, minus 8 equal to 0. You can factor it. But if you have x squared plus 4x minus 1, you cannot factor it. This one is good for factorization. This one, it is not good for factorization. Okay? It's not designed for that method. So this is a tricky method. Square root method is special. You must have something already very formatted. So x minus 2 quantity squared is 9, or like x plus 3 quantity squared is 5, something like this. Then you can apply the square root method. Take square root to get it. Completing, but the square root method is the starting point for the completing square method. Okay, because we know we can solve this, so we are going to investigate in order to apply the square root method. So we complete the square, right? So in the complete the square, we have those formulas, and we examine those formulas carefully, and we get completing square. After we get completing square, we see that's a very restrict steps. So you have step by step, you can find the answer. So we get the abstract completing square, we get root formula. We get the root formula. Root formula, x is minus b plus or minus square root of b squared minus 4ac over 2a. And this whole formula depends on the discriminant, b squared minus 4ac. It's positive, two different root, 0, a double root, negative, no root. Okay, so this is a universal method. It works for all quadratic quadratic equation, and factorization only works for some special one. And the square root method is the root of this quadratic formula. Okay, so for example, let's see if we have more example. If we have something like this, it's on page 102, 64. We have 2x over x minus 3 plus 1 over x is equal to 4. If you have such equation, now we don't care what method we have. We just have an equation, we try to solve it. For this one, it's not a quadratic equation. It's not a quadratic equation. But remember, this is a fraction. Whenever you have a fraction, you are going to multiply two sides by the common denominator. Now, the common denominator is x times x minus 3. So you're going to multiply two sides by x times x minus 3. So first one, x minus 3 canceled. You have 2x times this x. You have 2x squared. And the second one, 1 over x times this quantity, x canceled. You have x minus 3. And right hand side, you will directly get 4x x minus 3. Okay? And then you simplify it. You got 2x squared plus x minus 3 is equal to 4x squared minus 12x. And move everything to the other side. So you got 2x plus x minus 3 minus 4x squared and plus 12x is equal to 0. These two terms is negative 2x squared. X 12x is 13x minus 3 is equal to 0. Right? And from this step, we can apply the root formula directly. So x is, to apply before we apply the root formula, let's check b squared minus 4ac. B squared, b is 13, so it's a 13 squared is 100, what it is, 69, 13, 13, 9, 1, 3, okay, 169, minus 4, a is negative 2, c is negative 3, be careful, this is a, this is c, negative 2, negative 3 is a positive 6, minus 24. It's a 145. 145. All right, am I correct? Here you multiply x. Here you have x minus 3. Here's a 4 times x minus 12. Positive. Negative 2. Well, anyway, I hope I'm correct, but in any case, if I'm wrong, just send me email. Okay, this b squared minus 4ac is a 145. 145 is positive, so you have two different real roots. So you get x is negative 2a, denominator 2a, negative 4. Negative b is the 13, negative b is negative 13 plus or minus square root of 145. So the solution set is going to be negative 13 plus square root of 145 over negative 4, and negative 13 minus square root of 145 over negative 4. Well, I didn't do the check step because I know that if you let this product equal to 0, x is either 0 or x is equal to 3. Both numbers are not 0 or 3. If you after computation you get 0 or x equal to 3, then you cannot consider it as a root because it make this denominator 0. But here they are definitely not those two numbers, so I didn't do the check step. But I did it in my mind. Okay? So check. Both correct. Both are correct. Okay, let me write it down. Okay? So this is the answer for this problem. And once you get the square root of stuff which you cannot simplify it means the factorization method fails. So there's no way to factor it so that you can get the square root of stuff. Okay? Yeah. And the next difficult part of this section is application or the word problems. For example, let's try it. Let's try this one. Yeah, it's still on page 102, problem 92, Pythagorean theorem. Pythagorean theorem. What is a Pythagorean theorem? Pythagorean theorem says if you have a right triangle, this degree is 90 degrees. The right angle has two legs. This is opposite side. Then the Pythagorean theorem says a squared plus b squared is equal to c squared. This is a Pythagorean theorem. And the problem 92 says, let me rotate my Okay, this is 92. Okay, I'm trying to get this one. How many right triangles have a hypotenuse? The side opposite to the right angle is a hypotenuse. How many right triangles have a hypotenuse that measures 4x plus 5 inches and legs that measure 3x plus 13 inches and x inches? What are the dimensions of the triangle? Okay, so this is a problem. You can stop the window, stop the video and get the problem, and then we will continue. Okay? Okay, this is a problem. I'm going to rotate my camera. Okay, this one is a hypotenuse. The longest length facing the opposite to the right angle. This is a hypotenuse. The problem 92 says the hypotenuse is 4x plus 5. Two legs. For those two legs, there's no name. There's no name. So one leg is 3x plus 13. The other leg is x. So they want to know how many solutions for this. Okay? So the relation between A, B, and C is this is determined by this Pythagorean theorem. So you just plug in. So A squared plus B squared is equal to C squared. So this is the equation you get from the Pythagorean theorem. And then you are going to solve it. Okay, let's try to solve it. 3x plus 13 squared expanded. Remember that we have this a plus b squared is a squared plus 2ab plus b squared. So a is a 3x. 3x squared is 9x squared. 2ab, so 2 times this 3x times 13. 2 times 3x is 6x times 13 is 98x. 6x times 6x times 13. 6 times 13, not 90, 78. Yeah, so sometimes I try to verify it. It's a 78. 78. And then 13 squared, remember 13 squared, we did the computation, 169. Plus x squared is equal to this part. 4x squared is 16x squared plus 2 times 4x is 8x. 8x times 5 is 40x and plus 25. Okay. So we're going to move everything to the left hand side. So it's 9 plus 1 is 10x squared plus 78x and plus 169 and minus 16x squared and minus 40x and minus 25 is equal to 0. So we just move all the terms to the left hand side. And then let's try 10x squared minus 16x squared is negative 6x squared. 78x minus 40x is plus 38x. 169 minus 25 minus 25 is 144. Okay, well, this equation, let's divide this equation by 2 or by negative 2 because all the coefficients are even numbers. So I want a simple number. Smaller number will be easier to be computed. Okay, we divide it by negative 2. This one is divided by negative 2 is 3x. This one is divided by negative 2 is negative 19. This one is divided by negative 2 is minus 72. Okay. Well, okay, I have no idea how to factor it. Now let's try the root formula. B so not root, quadratic formula. B squared minus 4ac, B squared, B is this. Negative 19 squared is 19 squared. 19 squared, what is 19 squared? 361 minus 4ac. Be careful, this c is negative 72. So 4 times 3 is 12. So 12 times 72. 864 minus minus is plus, so it's 361 plus 864. 1225. 1225. I need. Okay, so this is positive, so you will have two roots. And then I'm going, remember later we will have square root. Remember the x is, when it is positive, you have two roots. It's a denominator 2a. 2a is 6. Negative b, 19. B is negative 19. Negative b is positive 19. Plus or minus square root of b squared minus 4ac. 1225. So what is the square root of 1225? I don't know what it is square, but let's try to factor and see what it can be. This way. It has the last digit is 5, so it can be divided by 5. Let's put 5 here. 12 over 5 is 2 divided by, so the remainder is 2, and 225 is a 4 and 5. So I'm trying to do this one. Leave 2 here. 20, you got 4, 5. Okay, so this means 1225 is equal to 5 times 245. And then you're going to continue. 245 is also a multiple of 5. It's a 4. Is a 9. Okay, so 1225 is equal to 5 times 5 times 49. Now I know what it is. 5 times 5 is a 5 squared. 9 is 49 is 7 squared. So square root of 1225 is going to be 5 times 7. You remove cancel square, it's a 35. So x is 19 plus 35 over 6, which is what this is. It's a 54. 54 but 6 is 9, or x is a 19 minus 35 over 6. It's negative 16 over 6 is negative 8 over 3. Okay, so you have two answers. One x is 9, the other one x is negative 8 over 3. Okay, so this part is just a simple computation. I'm trying to do the computation on the blank part. Well, I would not recommend you to write here on the answer sheet, but you have to write clearly and so that you don't make mistake. Anyway, I got x and x, but remember those x and x are the answers for the abstract problem. This is extra problem. We have to go back to the question. What is the question? What are the dimensions? How many right triangles? So we need to get A, B, and C. Check here. B is x. B is x. But B is one leg of the angle. So B has to be positive. So x cannot be negative. Okay, so this number, this negative 8 over 3 will be ignored. I don't need it. I don't need this. And then when x is 9, what is b? b is 9. A, what is A? A is 3 times 9, 27. 27 plus 13, what is this? Right? 3 times 9, 27. 27 plus 13 is 40. Holy. Okay, one is 40. C. C is 4 times 9, 36. 36 times plus 1, 41. Okay, so the dimension of the triangle is 9, 40, and 41. They are three sides of the triangle. Well, we can verify it. I'm going to verify it here. 9 squared is 100. 9 squared is 81. 40 squared is 1600. What is a 41 squared? 41 times 41, 1681. This is a b square. This is a square. This is c square. Well, they equal, right? It's a 1681. So it means our computation is correct. Our computation is correct. All right? Very good. Let's do another example. Those word problems are always a complex problem, especially when you have such large number. Large number make your computation difficult. What is the square root of 1225? It's 35, but you have to really factor the number and get the answer. Okay, let's see another example. Let's do more example. Let me see what example. Okay, let's see this problem. Wow. This business problem. Problem 101. This is on page, let me see what is the page number. Okay, 103. 103, page 103, problem 101. Reducing the size of a candy bar. A jumbo chocolate bar with a rectangular shape measures 12 centimeters in length, 7 centimeters in width, and 3 centimeters in thickness. Due to escalating costs of cocoa, management decides to reduce the volume of the bar by 10%. To accomplish this reduction, the management decides that the new bar should have the same 3 centimeter thickness, but the length of the width of each should be reduced an equal number of centimeters. What should be the dimension of the new candy bar? Okay, so you are going to reduce the size of a candy bar. Okay, so this is the problem. We want the volume reduced by 10%. Okay. Okay. This is assume this is a candy bar. Originally, the length is 12. The width is 7. The height is 3. Now you're going to shrink it. Okay? Let's assume we reduce x centimeters from the length and the width. Remember, they ask the length and the width should be reduced an equal number of centimeters. Equal number of centimeters. So you have x. Okay, and now what is a new candy bar? New candy bar looks like this. You reduce x centimeters, so the new length is 12 minus x. You reduce the width, so it becomes 7 minus x. And the height, they say the height is the same thickness. Same thickness, the height is still 3. Okay, so what is the volume of a new candy bar? It's a area of the base times the height. What is the volume of old candy bar? It's area of the base times the height. You want reduce the bar by 10%. So the new one is going to be 90% of the original bar. The new bar has a volume 90% of the original volume. Right? It is clear? Okay? Okay, now let's try to compute. This is the equation we have. How do we compute it? The left-hand side times 3, right-hand side times 3, they can be cancelled, right? Both sides have times 3 cancelled. So you have 12 minus x times 7 minus x is equal to 90% is 0.9 times 12 times 7. Okay, so we have to compute them. Well, let's do the product. 12 times 7, what is 12 times 7? Is 84. 12 times x minus 12x. X times 7 minus 7x. Negative x times negative x plus x squared. This is 0.9 times 84. Remember that, it times 84. Well, I don't want to do this multiplication. Let's try it. Well, it becomes x squared minus 12x minus 7x minus 19x plus 84. I move this to left side, minus 84 times 0.9 equal to 0. Okay, so what's this? You have a minus 90% of a. 90% off. 90% off means just 10%. So this difference is 84 times 0.1. Is like this, right? Minus 90%, remove 90%, you only have 10% off. Okay, then what's next? I don't know how to factor it, so I'm going to check the root formula, the quadratic formula, b squared minus 4ac. B squared negative 19 squared, I think we just did it, 361. I think somewhere we did it. Here, 19 squared. 361 minus 4, A is 1, C is 8.4. 8.4 times 4, 16, 3, 33.6. So it's a 361 minus 33.6. 4, 7, 2, 3. So it's a 300. Well, what this is? Do I need a calculator? Well, let's continue. This b squared minus 4ac is a positive. At least you have two roots. So x is denominator 2a. 2a is 2. Negative b, 19 plus or minus square root of 327.4. Well, you will have two solutions. X is 19 plus this quantity, and then 19 minus this quantity. Okay, so here let's see one thing. This problem unfortunately has, you need the calculator to get the estimation, but this quantity, if you use calculator, it's about, let me try to get the value. Use quantity. It's approximately 18.55, and this one is approximately, what is this? Is 0.45. Okay, it's a 0.45. Okay, so after you got those two numbers, you should know that this x equal to 18.55 is omitted. Why this number is not good? This number is good for this abstract problem again, but this number is not good enough for the real problem. The real problem, they are going to reduce the size. So this quantity cannot be bigger than 7, right? The original size width is 7. The length is 12. You are going to reduce some quantity. You cannot reduce 18 centimeters. You're going to adjust a little bit. So you can only select x equal to 0.45. You can only select x equal to 0.45. That will be the proper one. You remove a little bit, not more than total. Okay, so when x is 0.45, you get 12 minus x is going to be 11.55, and 7 minus x is going to be 6.55. So the new dimension of the candy bar is 11.55 by 6.55 and by 3 centimeters. So this is a new dimension. Okay, so I presented this problem. I'm not telling you you're supposed to use calculator in the exam. In the exam, I will carefully select some number so that you can either fact it or you can get the square root. So you don't have to worry about that. I presented this problem just tell you how you set up the equation. This equation is very important. Again, in the exam, you cannot use calculator. Okay? Okay, so do your exercise, and if you have a question, send me email. If I make any mistake, send me email. Okay, we finish this lecture. Thank you very much. Bye-bye.